Morning, guys. So, question 2 of the sample paper exam technique. Now, the thing I would do in this is, if maths is not your forte, question 2 is where all the maths is. Now, if maths is the hardest bit for you, which for a lot of DT/product designers, it is. What I would always do, the first exam technique, is always leave that to the end of the exam and do the other bits, which is mainly all writing, and then come back to this at the end. Okay. I'm going to go through the exam technique. I'm going to show you how to answer these questions, and then you guys need to give it a go. All right. So let's get started. Manufacturer of home accessories is looking to repurpose gardening products to bring a feel of the outside into small flats. So as a manufacturer is considering for a product which will be made from polypropylene, PP. The manufacturer considers using a similar shape to the existing pots for new indoor pots. A scaling ratio would need to be considered. Calculate the radius of the pot of the small pot. Okay, so basically it starts off nice and easy. So this is just working out what's the scale factor between the two of them. Now, exam technique. It's 2 marks. You've got to show you're working. Now remember, you are allowed a calculator in the exam, so that's fine. Now, this is going to be a pain to do it this week because I've not brought my work computer home. I've got my home computer, which hasn't got writing on screen technology. So what I have to do is this little sign-in thing. Add signature, which is really annoying. Okay. So first thing we need to do is find the scale factor. We've been given these two, and we're missing this radius here, which of course is half diameter. So all you need to do is put in 300 divided by 90, and that should give you, I can use my calculator on screen, 300 divided into 90, which gives you 3.33. Okay, or 3 over 10. Once you then do that, if you times that by 80, I think it was the other one, was it 80? We're going up or down? 80 divided by 3.33, because that's the scaling factor, and we're going down. We do 80 divided by 3.33, and we should get the answer of not that. Why has that come up? Hang on, let me just see that. 80 divided into 3.33, 24. That makes more sense. Okay, so your answer, always rounding, will be 24 millimeters. Started off nice and easy. Okay, next one. Now remember, it gets a little bit harder. So the next one is production costs. Table below gives production costs for the individual pieces shown in figure 3. Okay, so you've got the yellow pot costs that, the blue costs 11, the red tray costs 58. Now you have to work things out in DT. They don't give you all the answers. You have to look at the question. Maths questions in DT are like how they used to be. If you went back 20, 30 years, I think I've mentioned this to you before, so it's the 70s, all your maths papers wouldn't have just had equations. It would all been a big written text like this, okay? And then you would have to take the information and work it out, okay? Now, personally, I think it got made for the worse when you just had to learn the equations. But anyway, so you've got 2 blue pots, 1 yellow pot, 1 red tray. Okay, so your answer to this one would be, let's work out the worst ones. We had 2 blue pots, add signature. Oh, this is so irritating. Let's try this now. We had 2 blue pots, so you're going to have 2 times 0.11. Okay, you're then going to have 1 yellow pot, 1 times 0.10, and 1 red tray. So you're going to have 1 times 0.58. Now, same thing. Every bit of working, everything you think in your head, you do, no matter how easy it looks. Now we're looking for the percentage profit. Okay, now if we add all those up together, and I'm not going to do it for you, okay, it will be a certain amount. Okay, so if we call this question mark, okay, well, that doesn't work, is it? There we go. To work out the next bit, guys, okay, what you then need to do is work out the raw profit. Okay, so basically that would be the retail price minus the cost of how much it was to make it. So that would be £9, 9 minus question mark. Make sense? Okay. Now that would give you how much profit you've got. Okay. All you would then do is divide. Now again, this is where I might need to do some maths to make sure you're teaching it the same way I've done from many moons ago. You would do, come on, sorry guys, you would do £9.99 divided into whatever that was, and then times 100 to get your percentage. Now that should be easy as maths. That's basic kind of GCSE maths to work our percentage. Now a lot of these questions, guys, in DT will take one answer from here onto the next one. If you make a mistake, go away, on this bit, you can take it forwards. Now you can see this is 3 marks for this bit, guys. See, with all that working being shown out and being, I would have done a bit neater than this, neatly laid out for each bit, you'll be getting 2 out of 3 even if you make a mistake along the way. Okay, now this one, let's have a look. So after user testing, it's decided the dimensions of the pot need to be adjusted. So the radius of the top of the pot is 38 millimeters. The height is 90 millimeters, and there is a 5 degrees draft angle on all sides. Calculate the radius of the base of each pot. Okay. Right, so let me just need something to draw on. Now, if it was me, I would look at this and go, right, so they're changing the sizes of this up here, the radius of here, the angle. So this is going to be different. How am I going to work this out? Now, if it was me, I would be going straight back and drawing one of these because I'm very much a visual thinker. So if I need to solve a problem, I need to think things. So the first thing I would do is start drawing something. So I would go with, what can I draw on? Let's go to a PowerPoint, go to a new one. File, new. Let's just get rid of these. Sorry guys. And this one, can I draw lines on this? Insert shapes. There we go. So if you imagine, here is our pot. Okay, I'll draw another one off here. Shapes. Something like that. Okay. Now, if I prepared this video earlier, like old Blue Peter things, I don't know if you guys even know about Blue Peter, I would have gone, and here's one I did earlier, but I'm not that organised. So, as we go through, so imagine this is the pot. Okay, now what does it say? It says, the very top of the pot is 38 mil. So this is going to be 38 across here. The taper is going to be, this angle is going to be 5 degrees. Okay, and we need to know this bit down here, which we're going to put a nice big question mark in. Okay, because that's changed. Now that looks quite difficult to me straight away. I'd go, uh-oh, panic. How am I going to work out that if they've given me that? Well, I can see now I've got some sort of triangle in here. Okay. So I'd be thinking, right, I need to work something with triangles. So I'd be thinking, okay, let's go back to GCSE knowledge. SOHCAHTOA equal, but again, it's not much of a triangle. But then I'd be thinking, hang on, what happens if I put in the line here? Because if I work out what this is, so if I go, hang on, what's this? Because that's a square, or a rectangle, sorry, so that's going to be the same as that bit there. So if I can work out this bit here, then I can work out the rest. I've also, and have I forgotten to put a dimension in? Height is 90, sorry, you've forgotten something. So if I go text box, put this in here and go 90. So I know this line's 90. Need to know this one, I've got 5 degrees. So I have actually got a right angled triangle there, because that's going to be straight, that's going to be 90 in there. So I can now use SOHCAHTOA, yeah. Okay. Now looking at them, I've got the 90 degrees, I've got the 5 degrees. I need to know this one. Okay, it's got opposite and adjacent, we've got the hypotenuse, so it's going to be this one, the TOA. Okay, so I'd be thinking, which would be, so that's the adjacent, this would be the opposite. So I'd be thinking, right, hang on, so if I put this in here, that would be tan. My angle is 5 degrees of my draft. I don't know what my opposite is, so I'm going to do x divided into 90. So I need to reverse that, so it's going to be tan 5 times 90, not divided, to rearrange the formula to get x. And that would give me, let me just get my calculator up. Does it work on here? Now, this is where you see me not using this for so long. So 5, I'll probably put them in the wrong order, times 90 would equal 7.87. Okay, so the answer would be, let's just click back in there, 7.87. So that answer would be 7.87. So if I simply minus 38 from 7.87, it will give me that measurement there. A lot of working out just to find that. Imagine the real things if you could just use Fusion. Just scale it by whatever, and it would have given you the answer without doing the maths for you. But anyway, that's how you'd work that one out. All right? It's simple maths, but the hard thing is working out what to do and when. All right? So let's carry on. Here we go. If we scroll down, tray needs to hold 3 pots to ensure a comfortable pitch. Okay. The dimensions from the top of the pots are to be used to calculate the dimensions of the tray. There needs to be a 10 mm clearance gap between the top of each pot. Okay. There should also be a 10 mm clearance between the pots and the nearest inside edge of the tray. So how would we work this out? So we need to work out this distance for the length plus 3 tens. One, was it 10 mil? 1, 2, 3, 4 tens. So the way we would do that is this. We'd need to get the radius of this, times it by 2, times it by 3. So we would need to put in, to work out that distance there. So it would look something like this. We would look at it and we would go, I'm just going to see if I can do that. So if it, yeah, it does. So if it was 2r times 3, that would give us our distance across here. Now it's saying between each one there is a 10 mil gap. Okay, so it's 2r plus 2 times 10, which would give us plus, how many tens? Is it 10 between each one? Let me just have a look. Potential going to dimensions of the top of the pot. There needs to be a 10 mil gap in between the top of each pot. There should also be a 10 mil clearance between the pots. Okay. 2R times 3, and then that should be 10 mil times 4, because that would give you 1, 2, 3, 4. Now, if I'm correct, the width should be whatever that answer comes up as. And then you do the exact same for this one, which would be 2R plus 20. Okay, I think that's spot on. Yes, it is, I think. Yeah, and that will give you the answer that you're looking for. All right, next one. Oh, the other thing, I don't know if I've mentioned it. Always check your units at the end, especially A-level. They'll often try and trick you by changing the units to centimetres and millimetres at the end. They don't necessarily do that for GCSE in the GCSE DT paper. 2, working out as usual. And 3, make sure you read the question. And 4, make sure you reread the question later on. So I'd normally do this at the end. So I'd normally spend most of my time on the maths at the end. Okay. Final one. Okay. So figure 5 shows recess in the tray to locate each pot for stability. Okay, so the pot's just going to sit inside here. Figure 6 shows detail of the cross section of the tray. Okay, where's figure 6? So the side walls are 2 millimeters thick. The base is 4 millimeters thick. Okay, except the recesses for the plant pots, which are 2 millimeters deep and have a radius 1 millimeter larger than the radius of the base of the pots. Okay, so we learnt out that. So we've got that answer from before. So, way to do it. I would be sat here and thinking of a couple of different ways of doing it. The hardest way to do it, which would be complicated, would basically be if you work out this bit, then times that by the length, times that by 2. You'd have the area of those two there. You'd then need to also have 2 millimeters and do the same thing for the width, but also it'd get quite confusing because then you'd have to, if you did that for the full width, you'd have to take off 4 millimeters from the length, because obviously you'd work out this bit from there to there, say all the way from there to there, but you'd have this middle bit to work out as well. Okay, which is a bit confusing. The easiest way I would do this would be this. I would be thinking, let me have a look, let's just make a new page. The easiest way to do it would be, I think, something like this. If you had one bit, so imagine that's your outside bit. I'm not going to give you the answers, but you guys can work it out. You've also got the, I don't know why I'm not giving you the answers, you've got the answers at the end. So imagine you've got this one. Oh, if only I'd offset. And insert another shape, like so. Okay, imagine that was perfectly square. It's not going to be a PowerPoint. So to work out that bit, you could basically work out the full area, hopefully that you know as areas length times width. Then full out the length of the width of the middle bit. That would give you your outside bit first of all, which would give you, I'm guessing, one of the marks from this, because there's 5 marks to show everything. Okay. It shows you down here some other things, because I was a little bit nervous when I saw that, because that's not a very good picture, because that looks like it's got a tapered edge. But it says here that they are perpendicular to the base. You need to use the radius of the base of the pots that you calculated. And that's really nice. They've actually told you that you need to use the radius of C1. Okay, so that bit's the easy part. You've got the outside edge. You now need to know the volume, okay, of the middle bit with the recesses. So all you need to do is this. Okay. Give me a second. So you've got the outside bit. So how do you work out the area of a circle? Pi r squared. So all you need to do is take your answer from the radius of C3, which, did I put that one in? I can't remember if I made you do it. So we look up here. Oh yeah, so that one was whatever we decided it was. It was on here, 30.1. Come on. What do we say? That minus that, which I think is 30.1. That minus that, sorry. Okay, so the next part you would do is this. You would then, just whiz back down again. So much easier teaching in the classroom. Okay, so what you would do then is this. So you'll work the outside edge bit. So you'll have that bit already from that first square. The inside square minus the outside square, whatever it was, 2 millimeters or whatever. Okay, the next thing you do is this. You'd work out the volume of the inside bit by going, there's 3 of them. You're doing pi r squared, which I can't draw on my computer. So I'm going to type pi r, put a 2. You're listening to it, hopefully it'll make sense. So it'll be 3 times pi r squared. Except for I've forgotten one thing. Because we have to add in the extra centimetre size, it'd be pi r squared. It'd be the r, which we haven't worked out, you can do it either, would be the radius plus 1. So instead of being 30.1, it'd be 31.1. So it would be pi times 31.1 squared. Okay. And it'd be 3 times that, which is all good. And that would give you your inside area of your cylinders. And then what you would take from that is you would do 124, that number minus that, which would give you your overall number. So the only way to, how can I draw this without, I just need to draw on the screen. Sorry guys, this one's not going well because I can't draw on the screen. How am I going to do this? I'm just going to be rude and say, guys, I'm going to have to leave this one till we're back in the classroom. And I'll go through it with you but basically what you're doing, I can give you the exam technique, is you work the outside edge. You're working how much these are. Okay, how big those circles are to get the area, but then you need the volume at the end of them. So you're doing the pi r squared times, I think it was 2 millimeters, 2. Yeah, so you'd work out these ones. You'd add it to this one. So whatever you'd worked out from the square, you'd minus that from, and then you'd add it to that. So it's basically this square minus these middle ones added to that out one to get the area. That's probably clear as mud from this video, and I do apologize. What I will do is I'm in on Tuesday next week, and I'll bring my laptop home so I can actually draw on the screen, so it's a bit clearer. Okay. And then the final one, similar to GCSE, they always put in, even in the maths questions, they'll normally just put a random question at the end. Okay, it's normally on manufacturing, but it can be anything. So the end of question 2, I think it's the end, is, yeah, what you're looking at is this. So it's expected that the polypropylene PP tray will be manufactured in a batch of 10,000. Give 3 reasons, nice easy questions, why injection molded will be the preferred method of manufacturing for the tray in figure 3 and figure 5. So this is all on injection molding. Why do you use injection molding? Now, when you're answering first exam technique, you've always got to refer back to the pots. Now, we've always taught we keep drumming into your P, point, evidence, explain. Your evidence is in the question, so it's the pot. So if you don't mention the pot and you just go off on a big rant about how great injection molding is, and you've remembered that it produces a large quantity quickly, all these different things, but don't mention the pot, you will not get the mark because you haven't given the evidence. Okay, so first one is 10,000. So you need to produce a lot of them. It's given you one of the questions this way. Injection molding of this pot would be brilliant because it produces them a rapid succession to produce many pots. Okay, let's have a look at the question again. Find any answers. Okay, let's have a look at them. Okay, what are they? Oh, different colours. Oh, injection moulding uses different plastics of different colours. Oh, because the pot needs to be of different colours. There you go. Injection moulding produces different parts in different colours as needed by the pot. Something along those lines. You've just got 2 marks. Again, you've just taken all the information from the question. There's no outside actual knowledge you needed that. You just needed to look at the picture and be clever. Okay? Well, now, if you knew about injection moulding that we covered a month ago, you should know that it reuses its waste. Okay? The other way to do it for your 3rd mark is to go, so, you know, the sprue pins. So, you know, like the sprue where the injection goes in, the bit it's going would be hidden at the bottom there. So you could mention that injection moulding would be perfect because the only deformity or thing would be the sprue pins at the bottom that wouldn't even be seen at the bottom of the pot. So that's brilliant. The other way I would look at it is to go, right, well, what other method could I make these plastic bits out of? Blow molding? No, well, it's not kind of fully rounded. That's not going to work. What other methods do I know? Extrusion, not going to work because it's got the tapered edge. And you've got to seal it at the bottom. Vac forming. Could I vac form these? Yes. Why wouldn't I use vac forming? A, there's a large amount of them needed. Already mentioned that. B, what does vac forming do? Creates a lot of waste. So when you vac form, so imagine you had your former in there and it went into there, you have all that excess waste. So you have all that waste would have to be crumbled down, returned into a sheet would be a waste. Injection molding, on the other hand, as you know, all the sprue pins and stuff that come off can be reused again. So why is it going to be used injection molding? All the excess can be reused again to be used in. So you can reuse the stuff again and again and again. Okay? There's probably more answers in there. Why injection molding? Come on, brain, think. We've got colour. We've got uses all its waste, produces large amounts. Self-finishing. There you go. So there's another one. Self-finishing. So you don't have to do anything. So literally when they're made, they're finished, apart from cutting the sprue pins to speed it up. So the answers, again, guys, are all in the picture. So if you just look at it and go, right, what does that need? Why is that being chosen for that picture? You'd get the answer in that one. Okay, guys, sorry this one's been a bit rambling and I haven't been able to draw on the screen because that would have made it much easier. Next week I will have that facility back and hopefully the video 3 will be a bit better. Okay.